What if you could tear apart a Saturn V rocket piece by piece right in your browser with no download, no app install, nothing? That's exactly what I built. This is the Rocket 3D Explorer, interactive spacecraft 3D models, a browser-based 3D spacecraft library where you can inspect, rotate, and explore, starting with 5 of the most iconic spacecraft in history. And it's not finished, it's a growing library. Saturn V, Space Shuttle, Voyager Probe A, Voyager Probe B, and the Apollo-Soyuz docking mission. All of them fully interactive, all of them free. The site runs on Three.js, a JavaScript library built on top of WebGL, the browser's native 3D graphics engine. Three.js handles the scene, the camera, the lighting, and the orbit controls that let you rotate and zoom every model. For the build tool, I used Vite. It runs the project locally during development and gives you instant feedback. Save a file, the browser updates in milliseconds. For a project where you're constantly adjusting camera angles and model positions, that speed matters a lot. The 3D models are loaded as GLB files. GLB is the binary version of the GLTF format. Think of it like a zip that bundles your 3D geometry, materials, and textures all into one single file. It's the standard for Web3D because it loads fast, and Three.js supports it natively with a single loader. Now the workflow. I built this through vibe coding, working with multiple AI models as collaborators throughout the entire build. Not one AI, 4. There are Opus 4.6, Gemini 3.5 Flash on anti-gravity, GPT 5.5 on Codex, and DeepSeek V4 Flash on OpenCode. The loop is describe what you want in plain language, get working code back, paste it into the project, run it in Vite, see what happens, refine. That cycle, describe, generate, test, refine, is the entire development process. And because the library keeps growing, this workflow keeps paying off. Every new spacecraft I add, the AI helps me adapt the existing system. New card on the gallery, new model page, same structure. What took hours the first time takes minutes now. Building the site is one thing, getting people to actually find it is another, and that's where SEO comes in. For a growing library like this, SEO is not optional. Every new spacecraft page is a new opportunity to rank for a search term nobody else is targeting with an interactive 3D model. The first layer is the basics, a descriptive title tag with the keywords people actually search, a meta description that explains what the page does, a canonical URL so Google knows which version of the page is authoritative. The second layer is Open Graph and Twitter card tags, what controls how your page looks when someone shares a link. For a visual project like this, a strong OG image is the difference between a link people click and one they scroll past. The third layer is page speed, critical for a Three.js site. WebGL is heavy. The main optimizations: compress your GLB files, lazy load models so you only fetch a spacecraft when the user actually clicks it, and use WebP for all preview images. If the page is slow, Google penalizes your ranking and users leave before the model loads. Then structured data, schema markup, a JSON block that tells Google what kind of content this is. For an interactive tool, you can use the software application schema. It helps Google categorize the page correctly, which matters for how and where it gets surfaced. And this is where a growing library has a real SEO advantage. Each spacecraft gets its own dedicated page, its own title, its own keyword cluster: Saturn V 3D model, Space Shuttle interactive, Voyager Probe browser. The more pages you have, the wider the net. Every new model we add is also a new page that can rank independently. The library grows, and so does the search footprint. If you want more videos like this, breaking down how a real project was built, the actual tools, the actual workflow, subscribe. That's exactly the kind of content we're making here. And if you're starting your own Three.js project, get the GLB loader working first. Once you can load a model and see it in the browser, everything else follows from there.